All right, we're continuing on with reasoning here. Fill in some blanks and do some more work with reasoning. So the mathematical process involves experimenting, and if a pattern emerges, one can use inductive reasoning. So if you're using patterns, you're using inductive reasoning to generalize from the specific examples to all, and then you can write a conjecture about it. Okay. A conjecture may or may not be true. In order to prove a conjecture is true, then you use deductive reasoning. So deductive basically means that you have to prove it for all cases. If it is not true, if you can find just one example where it doesn't work, then you simply provide one counter example. So complete the next two rows, write a conjecture, and prove it. Okay, so let's look for some patterns here. So 1 plus 3 is 4, 3 plus 5. So what are these numbers? These are all odd numbers. They're consecutive. What do they add to? 4, 8. These are all multiples of 4. So if I follow this pattern, this would be 9 plus 11. So that's 20. And this would be 11 plus 13 is 24. Okay, so we're just going to kind of fill in below here. So what are we adding here? We're finding the sum of two consecutive odd numbers. Okay, and in this case, they're not integers. We'll call them, we didn't start with 0, so we'll call them odd natural numbers, just to be specific. And what's the result? Those are all multiples of 4, right? Or you could say results in a number that is divisible by 4. Okay? We want to prove the conjecture. So now with odd numbers, so this is the trick here. If you just say let x be an odd number, really you can't, there's no way to distinguish whether x is odd or even. Really it could be a natural number, it could be a rational. So we want to make sure that it's odd. Well, how do we do that? We do know that even numbers are all divisible by 2. So if we let k be a natural number, so that would be 1, 2, 3, 4, etc. Then 2k would be even. So the smallest natural number is 1. That would be 2. To get the smallest odd, we want to subtract 1. So this is an even number. Odds are always either 1 more than or 1 less. So if we're using natural numbers, actually to start with getting an odd being 1, we have to subtract. Be any odd number. So then let's find the sum. So of 2k plus minus 1, and then the next consecutive to that, every odd number we have to add 2 to it. So that would be, adding 2 to this would be 2k plus 1. So what's the sum there? That would be 4k. Minus 1 plus 1 is 0, so that's going to be 4k. And so a multiple of 4, you can see, so therefore since 4 is a factor, then the result is a multiple of 4. You just want to do it in the wording that you've used. Okay, so now let's look at the next example. So 2 squared minus 1 squared equals 3. 3 squared minus 2 squared equals 5, etc. So what are these numbers? So these are actually consecutive, starting with the bigger. We're squaring them. The next two rows then, this would be 6 squared minus 5 squared. This would be 7 squared minus 6 squared. So 36 minus 25 is 11. 49 minus 36 is 13. Okay, so what's happening here? If we are we're doing the difference, so that's a subtraction, of the squares of two consecutive these are natural numbers, and what do we get? These are all odd numbers. Is there anything specific about them? Well, 7 and 6 is 13, 6 and 5 is 11. So actually, the result is, so the difference of the two squares is the sum of the two natural numbers. Okay. So, natural numbers, so let k be a natural number. Okay, so then we wanted to take this would be the smaller one, so k plus 1 is the bigger one, consecutive, square it, minus k squared. So then figure out, expand that out, that'd be k squared plus 2k plus 1 minus k squared is 2k plus 1, okay? And then, how does that relate to the sum of the two numbers? Well, the two numbers were k plus 1 and k. So this is, if we split this up, that's k plus k is 2k plus 1. So there's the sum of the two numbers. All right, so give a counterexample to show that each of the following conjectures is false. So if you live in a country bordering the United States, then you live in Canada. So, yes, Canada borders the United States, but think about it. If you live in a country bordering the United States, how about Mexico? So that would be your counterexample. So this conjecture is not true. This is your counterexample. Okay? If a quadrilateral has 4 right angles, then it is a square. Okay, well, let's think about it. Quadrilateral is 4 sides. We have 4 right angles, 90 degrees. If I look at that, that doesn't look like a square. So counterexample would be a rectangle. The square is actually a special case of a rectangle. It has equal sides. Okay. Odd whole numbers less than 10 are prime. Okay. So odd whole numbers less than 10. That would be 1, 3, 5, 7, 9. Well, 9 is not prime. Okay, so 9 is a counterexample. Consider the conjecture. The sum of two prime numbers is an even number. Give 2 examples for which the conjecture is true. Okay, so how about, well, we know to get an even, if you add 2 odd numbers, you always get an even. So think of 2 odd prime numbers. How about 3 and 7? Okay, how about 11 and 13? Okay, so we've added 2 prime numbers and we get an even number. Give 1 counterexample that shows that the conjecture is false. What really, oftentimes when you're asked questions dealing with prime numbers, always remember that 2 is a prime number, and that's very different from all the other prime numbers in that it's the only even prime number. So if I had 2 plus 3, both prime numbers, I get 5. 5's an odd number. Okay, so that's a counterexample. All right, next one. In any isosceles triangle, all 3 angles are acute. So give 2 examples for which it's true. Isosceles means 2 angles and 2 sides the same. So an example, actually I can probably do that on this. something like this, okay, something like this. So these are equal. All of those angles, oh, actually that one's maybe a little bit bigger, okay, so that actually I should move down, right? So this one here, I'm going to move down. Let's see if I can do that. Why is it? There we go. Move down here because that angle is not acute here. This looks bigger than, so this is greater than 90 degrees. So that would be an example that doesn't work. I'll go back and do another one here. So this, how about that skinny one like that? Okay. Right? And these are all, each of them are less than 90, right? So actually I should do those the same and this different, just sometimes we do that for equal, and these are equal here, okay? Write a conclusion based on the following statements. If less than 20 people sign up for a computer course, the course will be canceled. Often that happens in courses. 12 people signed up for the computer class, okay? So conclusion would be that it's going to be canceled. Intersecting lines, opposite angles are equal. I've drawn two lines on there. So let's label them A, B, C, D. So when you're proving, you use things that have already been proved. So probably, I mean, you may have learned this already in junior high, but this would be a proof of it. You may just have been told or measured using inductive reasoning. In any case, one thing that you may have learned and tested out is a straight line is 180 degrees. So if we've got two angles forming a straight line or straight angle, it adds to 180. So A plus B equals 180, okay? Similarly, if we look at this line here, that means B plus C equals 180, all right? So let's see, we want to try to relate. Is A equal to C or B equal to D? Well, if I solve here, let's solve, what's common to both of these equations is B. So if I use substitution, back from Math 10, and I substitute in here into this equation, I would have 180 minus A plus C equals 180. And then basically I get negative A plus C equals 0. So then I get C equals A, right? So those are opposite angles, so that we just proved it. Next one, prove the difference between the squares of any two odd numbers is always divisible by 4. Okay, so we want to let n be a natural number. Remember, to get odd numbers, we need to start with natural numbers. Therefore, an odd number, we could do 2n, either minus 1 or plus 1. So I'm going to do minus 1, okay? Because if that was a 1, 2 times 1 is 2, minus 1 is 1, okay? If you use natural numbers, then whole numbers, you'd want to start with 2n plus 1. But an odd number, 2n minus 1. Notice this says any two odd numbers. So they don't have to be consecutive, okay? So then another odd number would be, let's use k, 2k minus 1. So I'm going to let k and n be natural numbers. I need to do it twice, okay? And then it says the difference between the squares. And we don't know which is which. So I'm going to just write out the squares, difference. It doesn't matter which you put first, and figure out what that is. I'm not going to say it's equal to something with 4 in it. I want to see what happens. Okay. So now you use your algebra skills. Oops. And you'll notice that the ones go away. Then we have everything here has a factor of 4. So now I can factor out a 4, k squared minus k minus n squared plus n. Always, like, even though you see each term has a 4 in it, factor it out. To be a proper proof, we want to see that 4 is a factor. That means it's divisible by 4. Okay? So since, you need a statement at the end, since 4 is a factor of the result, then the result is divisible by 4. Notice the different wordings. Divisible by 4 also means it has a factor of 4, but I had to state it both things, right, to get it from here to the final statement. And that's it.